Good evening, everybody. Today we will start our first lesson in the analytical geometry for Prep 3 in the first term. The first topic we are talking about it is the distance between 2 points, how to find the distance between two given points. As you see in this opposite figure, I have 2 points as we studied before, that the 2 points like M and N, each of them is written as an ordered pair. And what is the ordered pair? As we studied in our algebra, that the ordered pair is representing the distance moved, or the part cut from X and Y. So I moved here on X, then I go up on Y. So that as you see that M is called X1 and Y1. I don't mean that the value of X is equal to 1. No, I'm here telling you that it's the first point, so it has the first X and the first Y. What about N? It has the second X and the second Y. To find this distance, this is the difference between x2 and x1. So I can write that AB is x2 minus x1. And what about this distance, which is y2 minus y1? Because it's the difference between the second y and the first y. And also for the horizontal distance, it will be the difference between the first y and the first x and second x. So to find the distance between M and N, I will do it by using the Pythagoras theorem, which is saying to me that the square of the hypotenuse, or to find the hypotenuse, we will put square root on each of the two adjacent sides of the right angle squared. So I can say that Mn equals this side power 2 added to this side power 2. So as we said, this side is x2 minus x1 and here y2 minus y1. So in general, we can say that the rule of the distance between 2 points will be square root x2 minus x1 raised to the power of 2 plus y2 minus y1 raised to the power of 2. Or in general, we can say that the distance between 2 points is the square root of the square of difference between x coordinates plus the square of difference between y coordinates. Let's move to solve some examples and get in deeper. The distance between the 2 points 6, 0 and 0, 8. Okay. As you know, that's 6 and 0. This is x1 and y1 and 0, 8, x2, y2. To find the distance between 2 points, let's remember together that our rule was telling us that the distance will be square root x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. So I will do it like this. It will be 0 minus 6 power 2 plus 8 minus 0 raised to the power of 2, which will be equals to 10. Very important note here. When you are finding the distance between 2 points, this distance should be positive, because I can't find any distance with a negative value. Okay, again, let's apply for another question. This next question is asking me to find the distance between a given point and the origin point. What about the origin point? As we said before, that the origin point is 0x and 0y. So to find the distance, I will put it like this: square root 2 to the power 2 plus 4 to the power of 2. Hey, mister, you should write square root 2 minus 0 power 2, 4 minus 0 power 2. So what is the value of 4 minus 0? Which is equal to 4. What is the value of square root 2 minus 0? It will be square root 2. So I will find that this value will be 2 square root 2. We will find that this value will be square root 18, which is equals to 3 root 2. This point is very important. The distance between -7, -3 and y-axis. To find the distance with y-axis, you should take the value of x, or x coordinates. So I will choose -7. No, it's not negative. As we said before, the distance should be always positive, so it's 7. So when I'm asking you about the distance with y-axis, if I have a point which is called A or B, we have 2 points to discuss. To find the distance with x-axis or to find the distance with y-axis. To find the distance with x-axis, we will take the y-coordinates but in an absolute value. And to find the distance with y-axis, we will take the x-coordinates but also in an absolute value. Why should we use the absolute here? Because I can't find any distance in negative. So to make sure that it has a positive sign, I will use this absolute value. Okay, let's move to the next part. A, B, C, D is a rectangle, as we know, and as we studied before, that the rectangle, each two opposite sides are equal in length, and also its diagonals are equal in length. So he's asking me about BD, and the given is about AC. Note that AC equals BD. Why? Because the diagonals of the rectangle and also the diagonals of the square are equal. So I will make it like this: 2 minus negative 1 to the power of 2 plus 1 minus negative 3 to the power of 2, which will be equals to 5. Let's move to the next part. If the distance between 2 points A and 5, or 3A minus 1 and 1, equals to 5 units, find the value of A. I will write and I will solve an equation to find the value of A. How can I do it? Look at this. Let's apply our rule. 3A minus 1, x1, x2 minus x1, A raised to the power of 2 plus y1 minus y2 minus y1, 1 minus 5 raised to the power of 2 equals to 5. And I will use my skills to find its value. First of all, to remove the square root, I will apply power 2 for both sides. This power 2 will cancel the square root. So here, 3a minus 1 minus a, which is 2a minus 1, raised to the power of 2, plus 1 minus 5, negative 4, raised to the power of 2 equals 16. 5 raised to the power of 2 equals 25. The next step I should do is I will subtract the 16 from both sides. 2a minus 1 to the power of 2 will be equals to 9. What about removing the square root? How to removing the power 2? How to remove the power 2? I will apply square root for both sides. But when you are applying the square root for both sides, don't forget that when applying a square root to 9, it will be positive or negative 3. Not only positive 3, but also I will write it like this: 2a minus 1 equals 3, or 2a minus 1 equals negative 3, because the square root of 9 will be positive or negative 3. Now I'm solving a first degree equation, which is very simple, I think, putting 1 with the positive sign, so 2a equals 4, and now I got that a equals 2. Okay, let's move to the next one. I will put 1 here in the positive sign, so 2a equals negative 2, and I got that a equals negative 1. So again, I wrote my rule, and after writing my rule, I follow the steps to solve an equation, but please don't forget that on applying a square root while solving an equation, don't forget to put positive or negative sign. Let's move to the next example. Prove that ABCD is an equilateral triangle. What is the meaning of an equilateral triangle? Oh, I know that the equilateral triangle is the triangle whose sides are equal. So he is asking me now to prove that AB is equals to BC equals to AC. So may I ask you a question here? What are the different kinds, or what are the different types of triangles according to its side length? The first one is the equilateral triangle, which has 3 equal sides. What about the next one? The next one is the isosceles triangle, which has only 2 equal sides. And the last one is called the scalene triangle, which has no equal sides or no equal angles. So let's apply our rule now. I will calculate AB then I will calculate BC, then I will calculate AC. Let's go. AB square root 6 minus 2 raised to the power of 2 plus 0 minus 0 raised to the power of 2, which is equals to 4. Now let's do it the same step for B and C. Square root 4 minus 2 squared plus 2 root 3 minus 0 also raised to the power of 2, which is also equals to 4. The last one is AC. How to calculate AC? The same step. I will make it square root 6 minus 4 raised to the power of 2, 0 minus 2 square root of 3 raised to the power of 2, which is equals to 4. So I'm telling him that since AB equal BC equal AC, since I found that AB equals BC equals AC, therefore triangle ABC is an equilateral triangle. Now let's move to this point. How to find the area of triangle. I will draw a simple triangle to discuss it on this triangle. Here I have A, B, also C. This is 4 units, 4 units, 4 units. The area of triangle is half multiplied by base multiplied by height. So I need to write or to draw this height here. If I said that the height, it has a name AX. As you know, in the equilateral triangle, X is the midpoint of BC. So I have a right angle triangle here 2 and its hypotenuse is 4. So to find the length of AC, I will use the simple rule of Pythagoras. Square root 4 power 2 minus 2 raised to the power of 2, which will be 2 square root of 3. Now I have the area rule. All its unknowns are found. So we can write that area of triangle equals half multiplied by base multiplied by its corresponding height, which is half, times 4, which is the BC base, times AX, which is 2 square root of 3. I found that my area is 4 root L3. Let's move to the next part, which are some important remarks. Let's talk it. The first remark I have is to prove that 3 points are collinear. What is the meaning of the word collinear? Collinear it means that they are contained on the same straight line. They lie on the same straight line. So if I have 3 points A, B, and C, as you see, A, B, C, to prove that they are collinear, I will find the distance between A and B. Then find the distance between B and C, and also find the distance between A and C. I will find that these two smaller distance, if they are added together, they will get to me the longer distance, so that they are collinear. The second remark, which is very famous in our exams, to prove that A, B, C are vertices of triangle, we should prove that any side is smaller than any side is smaller than the sum of 2 other sides. But to be more accurate, to prove that these vertices are the vertices of triangle, you should prove that the longer side is smaller than the sum of the 2 smaller sides. What about determining the type of triangle according to its angles? We studied before, or we said it before, how to find or determine the type of triangle according to its sides, equilateral, isosceles, and scalene. Now, according to its angles, I have to find, is it an acute angle triangle, or an obtuse angle triangle, or a right angle triangle? First of all, you should find the length of the 3 sides. After that, you will make as follows. The biggest side, it's not for sure usually AC. Here I'm asking you to measure the longest side. If the longest side raised to the power of 2 is greater than the sum of the squares of 2 other sides, or the 2 smaller sides, then it's an obtuse angle triangle. And if they are equal, then it will be a right angle triangle, and if the longer side raised to the power of 2 is smaller than the sum of two other sides, then it's an acute angle triangle. Let's apply by solving a question. Prove that the triangle ABC is a right angle triangle, then find its area. It's okay. I will find AB, then BC, then AC. And I will take the longest side to make it power 2, and I will find it equals to the sum of the squares of two smaller sides. Let's proceed. The first one is to find the distance between A and B. I will make a square root x2 minus x1 negative 4 minus 3 raised to the power of 2 plus 1 minus 2 raised to the power of 2, which is equals to 5 square root 2. Now let's move to BC. Square root 2 minus negative 4 power 2 plus negative 1 minus 1 power 2, which is 2 square root 10. And now the last one is AC, which is equals 2 minus 3 raised to the power of 2 plus negative 1 minus 2 raised to the power of 2, which is equals to root 10. Now I will take the bigger side, which is 5 root 2, AB squared plus, AB squared equal the last point I will do, or the last step, is to take the longest side, which is AB, and trying to make it square. So AB squared will be equals to BC squared plus AC squared. Let's check. 5 root 2 raised to the power of 2 equals 2 root 10 raised to the power of 2 plus root 10 raised to the power of 2. This will be 50 and the other side will be 50, therefore it's a right angled triangle. Now, how to get its area? As you know, the area of the right angle triangle is half the product of the two perpendicular sides. So area will be half multiplied 2 square root 10 times square root 10. So I think the area will be 10 units. Let's move for the next remark. In this remark, he is helping you to how to prove that I got a quadrilateral, as we studied before that the quadrilateral has 4 sides. How to prove that this quadrilateral is a parallelogram. In the parallelogram, we studied before that each two opposite sides are equal in length. So to prove that ABCD is a parallelogram, I will prove that AB equals to CD and AD equals to BC. What about to prove that ABCD is a rhombus? What is the difference between the rhombus and the parallelogram? The rhombus is a parallelogram whose all sides are equal in length. So that to prove that ABCD is a rhombus, I should prove that AB is equal in length with BC and CD and also DA or AD. Let's move to the next one, how to prove that ABCD is a rectangle. What is the difference between the rectangle and the parallelogram? I know that in the rectangle each two opposite sides are also equal, so I will prove that AB equals to CD and BC equals AD. Up till now it's just a parallelogram. What is the added property to the rectangle? I think the added property is that in the rectangle each the diagonals are equal in length, so I should prove that AC is also equals to BD, and this is also the same difference between the square and the rhombus. Both of the square and the rhombus have equal sides, so if you said that AB equals BC equals CD equals DA, this is a rhombus, not a square. How to make it a square? As you studied before, the square is a rhombus whose diagonals are equal, so you should find or prove that AC is equals to BD to prove that you have two equal diagonals, then it will be a square. Let's move to the next point. Remark number 4. The axis of symmetry of the line segment is the perpendicular bisector to the line or is a straight line which is perpendicular at its midpoint. As we studied before, any point lies on the axis of symmetry of the line segment is at equal distance from its two terminals. So, to prove that C lies on the axis of symmetry or belongs to the axis of symmetry of AB, you should prove that the distance between A and C is equals to the distance between C and B. The last remark is how to prove that I have more than one point lie on the same circle. The famous property of the circle that we studied before is all radii are equal in length. So if I have a circle whose center is M and I want to prove that A and B and C lie on the same circle, you should prove that the distance between M and A is equal to the distance between M and B and also equal to the distance between M and C, because it's only one point which is equidistant from all points on the circle, so that MA is a radius, MB is a radius, and also MC will be a radius. Remember that the circumference of the circle is 2 pi r and the area of the circle is pi r squared, and moreover don't forget that the diameter of the circle is twice its radius length. Let's solve an important question. In this question, he is asking me to prove that the points A, B, and C lie on the same circle whose center is M. So I will prove that the distance between M and A equals M and B equals M and C, and all of these lines will be radius. So let's start. M and A, 2 minus negative 2 raised to the power of 2, negative 3 minus 0 raised to the power of 2, it will be 5. MB, square root 2 minus 5 to the power of 2 plus negative 3 minus 1 to the power of 2, it will be also 5. And MC, square root 2 minus 6 raised to the power of 2, negative 3 minus negative 6 raised to the power of 2, it will be also equals 5. So I got that. Since MA equals to MB equals to MC, therefore A, B, and C lie on the same circle M. The last point is to find the circumference in terms of pi. In terms of pi, this means that we don't need to calculate the value of pi. I will write for him the rule circumference equals 2 pi r, so it will be 2 pi multiplied by 5, which is equals to 10 pi. Let's move to another example. Here, this is an important example to find the value of A. If the distance between the 2 points A and 7, negative 2, 3 equals to 5. Let's apply our rule. As we said before, A minus negative 2, which will be A plus 2 raised to the power of 2, and 7 minus 3 raised to the power of 2 equals to 5. How to remove the square root? As we said it before, by applying power 2 for both sides. The power 2 will cancel the square root. So I have A plus 2 all to the power 2, 7 minus 3, which is 4, raised to the power of 2 will be equal 16 equals 25. The next step is to subtract the 16 from both sides. So A plus 2 to the power of 2 equals to 25 minus 16, which is equal to 9. How to remove the power of 2? I will apply square root for both sides, but please take care and don't forget A plus 2 once will be equal 3 and the other time will be equals to negative 3, because when I apply the square root, once it will be positive and the other time it will be negative. Now I'm solving an equation to find the value of A by putting negative 2, so 3 minus 2, I think here A is equals to 1, and the other side I will subtract 2 from both sides, so A will be negative 5. So here A have two different values, one of them is 1 and the other is negative 5. By the end of this video, we have finished the first lesson in our analytical geometry curriculum, so please take care that you should keep your rules well and you should solve all these examples by yourself. I wish you good luck to meet on another video. Have a nice day.